seen you lose your way and not in control, and you won't be told. All I can do to keep you safe is hold you close till you can breathe on your own, till you can breathe on your own. Hold tight, you're slowly coming back to life. I've been giving you hell, I've been giving you hell. Let go of all your wanted dreams tonight. I've been giving you hell, I've been giving you hell. Hold tight, you're slowly coming back to life. I've been giving you hell, I've been giving you hell. Let go of all your wanted dreams tonight. I've been giving you hell, I've been giving you hell. And I won't let you down.
This is CS50, week 11 for the final time, and it is, of course, this weekend Harvard-Yale, and in full disclosure, we actually spent yesterday at Yale wrapping up the course there as well, but we did think this was perhaps an opportunity to make a few changes here for today's lecture. Now, to be fair, we suck, but we thought we'd use this as an opportunity to take a closer look at this problem that was solved by some of our friends in New Haven just a few years ago in honor of this weekend's event. A closer look then at, if you will, problem solving.
We're headed up to Boston, checking out the stadium for the prank. A few years ago, I was at a math conference, and I was sitting around at a table at dinner with a few other mathematicians. And one of them went to Harvard and started telling the story of this amazing prank that was, against Harvard. And at that point, I felt I had to interrupt and said, well, actually, I can tell you a lot more about that.
Okay.
The idea was perfected in a dorm room.
Came up with the idea, actually, to prank them with signs at the football game. We threw some ideas out there as far as what the signs would say. We eventually settled on "We suck."
And my immediate reaction was, no, this will never work. However, the problem solver in me started thinking, well, maybe we can make this work.
The problem? They had to infiltrate Harvard Stadium without getting caught, sneak in 1,800 placards, distribute them to unsuspecting Harvard fans, and then convince those fans to prank themselves.
That's great. We thought about basically every possible thing that could go wrong and tried to come up with a solution for it.
And then you put 2 reds on top of it.
They made fake Harvard IDs and fake backstories, fake placard designs, and a 28-member fake pep squad. On November 20th, 2004, a fake Harvard student smuggled the placards into the game.
What do you think of Yale, sir?
But then, trouble.
What houses?
How many extra are there? Sometimes.
Yeah.
I, just showed him the front of this ID, and all of a sudden he just ran away, and he felt so embarrassed.
Having escaped one confrontation, they couldn't risk another. It was time.
This just looks like a total mess. We have absolutely no idea if this is going to work.
Look at them, they have the over. It's gonna happen. It's actually gonna happen. I can't believe it.
What was once a prank became a legend.
And immediately we started hearing chants from the other side, "You suck." And I think it was at that point in time that we knew we had pulled it off. I really think it didn't matter that Harvard won because of the prank. For a lot of Yale students and alumni, we definitely won that year.
Well, best of luck to both teams this weekend. We thought, though, we would participate in our own CS way. This game was something written in Scratch some years ago now by one of your predecessors, and I thought we would go head-to-head here with Yale, if we could, with one volunteer who was willing to come up and represent Harvard in this game. Someone? Anyone? Not too many people all at once? No? Actually, would you, with the Harvard sweatshirt, like to play this game? Could we get you to come on up? Are you comfortable? Yeah? All right, come on up. This could not be more perfect. What's your name? Diana. Diana, nice to see you. Come on up, Diana. So here, as you see, we're about to hit the space bar, and the instructions will appear on the screen if you'd like to play at my keyboard here. And the goal is simply to move the Harvard crest to the goal again and again without getting hit by the other team. Okay. Sound good? And just arrow keys up, down, left, right. Oh. Surprise. Let's actually open up the game. That was a slide. There we go.
You can't touch this. You can't touch this. You can't touch this. You can't touch this.
Nice. You have your fan.
Music hits me so hard, makes me say, oh my Lord, thank you for blessing me. What am I to run and
Two Yales now.
when you know you're down? A super dope homeboy from the Oak Town, and I'm known as such. And this is a beat you can't touch. I told you, homeboy, you can't touch this. Yeah,
Very nice.
you know, you can't
Level 5.
Look in my eyes, man. You can't touch this. Here, let me bust the funky
Nice.
fresh new kicks and bands. You gotta
Level 6.
out of your seat and get a fire girl and catch this beat while it's rolling. Hold on, pump a little bit and let them know what's going on like that. Like that. Hold a little bit just to fall on back. Let them know that you're too much. And this is a beat they can't touch.
Oh.
You can't touch this. Why you standing there, man?
Nice.
You can't
Yes.
Yo,
Yes.
sound the bell. School
Level
is in.
7.
You can't touch this. Give me a song or rhythm, making them sweat. That's what I'm giving them now. They know. You talk about the hammer, you're talking about a show that's hot
Nice. Level 8.
and tight. Singers are sweating so fast, I'm a white rock tape. To learn what it's gonna take in the 90s to run the charts.
Oh.
If you work hard, well, you might as well quit. That's word because
Oh. Still level 8.
you can't touch this. Break it down.
Yes. Level 9. Second to last level. Oh. Death at 5.
It is said if you can't prove this, then you probably are dead. So wave your hands in the air.
That's okay.
Run your fingers through your hair. This is it. For a winner.
One level to go after this. Yes.
Slide your rump just for a minute. Let's all do the bump. Yeah. You can't touch this.
Okay.
Look, man. You can't touch this.
Yes.
Gotta get hype, boy, 'cause you know you can't touch this.
He's at once at a
Ring the bell. School's back in. Break it down.
Level 9. I know better. Okay, nice. Yes. Ooh.
Hammer time.
Oh, don't give up yet. Yes. Yes.
You can't touch this.
Hang in there. Let's give it another one or two more deaths. Hang in there.
You can't touch this.
There you go. Come on, Diana. Come on. Yeah. One more.
Stop. Hammer time. Every time you see me, the hammer's just so hype. I'm dope on the floor.
Hang in there.
Magic on the mic. Now why would I ever
Come on.
stop doing this with others making records that just don't hit? I pull around the world.
Try a couple more times.
It's hammer go, hammer hit the hammer, yo,
What's that?
hammer, and the rest can go in play.
I think you just luck.
Can't touch this.
One more life. 2 more lives.
You can't touch this. Yeah. You can't touch this. I told you. Can't touch this.
Yes.
Too high, can't touch
One more. All right, one more.
this. Yeah, we out of here. Can't touch this.
Yes. Yes. Oh. All right. A big round of applause for Diana. Congrats. Thank you. All right. So we will post a link on the course's website if you would like to try your hand at that as well. Before we forge ahead, though, a big thanks to CS50's whole team. Suffice it to say, with office hours and sections and the problem sets and soon the CS50 Hackathon and Fair, we truly could not do it without all of these faces here, all of the faces behind you today, and the whole team online. So if we could, a big round of applause for CS50's team. Allow me to call out a few folks in particular. One, these are all of the names of CS50's staff, both here and afar, helping to make this course possible. CS50's production team, of course, making it possible for you to tune in across campus or across the world. And then some folks, too, that might be more familiar over the course of the semester. CS50's own Doug Lloyd, who not only has been the longest-serving staff member for the past 11 years now, he was also here on Jeopardy some years ago and won. So that was amazing to watch on TV. CS50's own Rob Bowden, or that guy in Thayer from whom you might have gotten some help over time since he's a proctor there. And of course, perhaps the most familiar face of all, CS50's own Zamila from the problem sets. And then, of course, today's performer, playing out, if you will, problem set 3 for us, Brian. A big thanks to him as well. And then a special final thanks to someone particularly special, CS50's own Maria, who has been with the course now in some way for 4 years. Sadly, but excitingly, Maria is about to go off into the real world working as an engineer at Facebook, but she actually took CS50 here as a first year years ago, and then is among the longest serving members of the course's heads team in that she's been with us now in some form for the past 3 years. And in fact, we went through some old footage, and in fairness, one of her friends actually found this an old video from her freshman year years ago. This was Maria, like right here, volunteering some years ago. So if we enhance this here, a big round of applause, especially for Maria. She will be missed. As, of course, will you. So this is week 11, and so this is where we promised we would get to. And indeed, especially on the heels of a little quiz that you might have taken or finished yesterday, what does ultimately matter in this course is not so much where you end up relative to your classmates, but where you end up relative to yourself today and next week and beyond, relative to where you were in week 0. So we do hope that you have gotten an extraordinary amount of time back now from this class, but also a huge return just in terms of the concepts and the practical skills we hope you can now bring to your future studies in CS, or if you exit CS at this point, to your own domains and can solve problems all the more effectively. And in fact, if you're curious as to how some of your classmates have labeled themselves over time, this is where in week 0 you all were, with the majority of the class describing themselves as less comfortable. And if you're still feeling a little bit that way, rest assured, some 12 weeks later, none of you are among those less comfortable anymore. Everyone has been upgraded as of today to somewhere in between or more comfortable, so do realize that too has been a stepping stone. And in fact, now, even if you are currently a first year, or we've had high school students in the past, or a junior and a rising senior, realize that the opportunities ahead not only to study other courses in CS, but to teach computer science, TFing or CAing for CS50. Hands down, the most effective way to learn this kind of material and perhaps any other is to actually teach it. And that's certainly true for me and for Maria and Brian and Zamila and Doug and Rob and the whole of CS50's team here. I mean, in fact, some of them with CS50's production team wanted to share with you an invitation to join us in some form on campus this coming fall 2018, online in the meantime, or in any number of other ways, if we could dim the lights for this invitation from the staff.
I'm Elisha.
My name is Nenya.
I'm Athena Braun. I'm a sophomore.
I'm a senior.
I'm a junior studying computer science and linguistics.
I'm concentrating in CS now.
CS50 is also just because it's like changed my life. It made me a computer science concentrator.
I am a TF for CS50.
Course assistant.
This is my second year TFing now.
This is my third year being a teaching fellow for CS50.
Becoming part of CS50 staff helped empower me so much.
I was a total beginner. Never anticipated programming beyond CS50, but here I am. Which is something I never thought I would do. And I think it's just been really exciting going from being a beginner to being comfortable enough to TF this class.
Everything that has come out of this has helped me grow so much as a teacher, as a student.
Also the culture and like the environment of it is also pretty unique.
I've definitely like found a community of friends within the CS50 staff.
Be prepared to have students who like look up to you and really appreciate the work that you're doing, and like just realize that you're not just a teaching fellow, you're not just this like person behind the whiteboard, you're like a student who took this too and can really level with other people in your section and figure out what's going on and like make it a good experience for them.
I decided that I can get the best of both worlds. I can get to teach about computer science, and those are two of my passions.
I just really love teaching computer science to beginners. CS50 is where all that beginner energy is, and it's where I can like make a real impact on sort of the students' careers in CS.
It's amazing to see how much this course can do in just a semester, and how from September until December, students learn so much and gain so much experience and knowledge, and watching that and working with them in that process has always been really, really inspiring.
It's been so wonderful getting to see these people grow, just like I did myself.
One of the most rewarding things I've done here, so that's why I keep coming back.
Going to office hours and helping people out, it makes you feel good, and it makes other people feel good as well.
My name is Brian.
I'm Thomas Lively.
I'm Allison.
I'm Maria, and this is CS50.
So in the coming weeks, please do feel welcome and encouraged. Even if you were among those less comfortable and still kind of think you are, that is undoubtedly not the case, because among CS50 staff are students who have just taken the course a year or two or more prior, you potentially among them. And in fact, there's other opportunities to get involved as well. In addition to the on-campus class here, we of course have our friends in New Haven, but even beyond, does CS50's team work with communities around the world. In fact, every red dot on this map here represents a high school where there's a high school teacher and class of students who are taking CS50 in some form, where their own teacher has adopted or adapted the curriculum, the same tools, the same software that you all use here in Cambridge and in New Haven to actually teach introductory computer science as well. In blue, similarly, our universities around the world as well, where we've been working with faculty and student groups beyond. In fact, here are some of our friends in Miami-Dade College in Florida, some of our friends here in Chile, here in London, here in Burma, here in Ukraine, here in Cairo, here in Bolivia, here in Nicaragua, and lastly, here on stage, our very first cohort, so to speak, of high school teachers teaching CS50 AP as of a couple of years ago, who then went back to their own school districts to evangelize computer science and empower students there to teach it. And in fact, even though we ourselves have our own hackathon coming up here in just a couple of weeks' time, so has there been a CS50 hackathon for high schools. In fact, pictured here was our very first CS50 hackathon for AP students, a mix of 4 public, 4 private schools in Manhattan some months ago, where everyone got together to work on their own problem sets, projects, and the like. So again, please feel free to engage in any number of these ways and more. So what did we do all semester, and what will you do if you continue to apply CS? So it's really all about problem solving, and we've certainly solved quite a few problems, the last of them last week with problem set 8. If you're curious as to what your classmates thought of the problem sets, here we have blue means love, and purple purple means hate, and each of these bars represents problem set 0 through 8. So you can kind of get a sense where the love, where the like, where the neutral was here in yellow, and maybe some spikes of hatred, maybe over down there. But perhaps more revealingly, too, is the difficulty with which folks perceive these. And this admittedly is retrospective. So of course, Scratch was pretty fun, pretty easy, as was maybe Mario and so forth. But you can get a sense of some of the fluctuation. And apparently, on the heels of misspellings here, we suddenly went to a lot of medium difficulty when you simply had to port, so to speak, some of your problems from Pset 1 now for problem set 6. And in terms of demographically how your classmates are engaging in the class, when did you start problem sets? Oh, interesting. So recall that problem sets are released on Fridays. And here we have Saturday, Sunday, Monday, Tuesday. Oh, hello, Wednesday is when really a plurality of students seem to begin their problem sets. Not, though, perhaps surprisingly, when it coincides with office hours and sections in the earlier days of the week. And then in terms of when you watch lectures, because indeed, both here and in New Haven, most students today do engage online, you can see that with the lectures live on Friday, many students watch apparently shortly after 10 a.m. on Fridays, but on demand, followed by the weekend, and the most popular being Monday before sections, presumably. So you, too, are somewhere among those inputs. But what were the problems that we actually solved, and what were really the goals of the class? It's not to teach C per se. It's not to introduce JavaScript or SQL or Python, all of which are really just tools in a toolkit so that when you exit CS50 and go on to some other class or some other field and want to actually solve problems using data and using computation, that you actually just have a mental model with which to approach it and less of a fear factor, so that even if you have absolutely no idea how to write code in Ruby, which your lab or your company, your friends happen to be using, well, no big deal. Much like in Pset 7 and 8, where Google and Stack Overflow and friends become your support structure, realize that among the goals has been to teach you to teach yourselves. And undoubtedly, that comes with some frustration in especially those recent weeks. But the goal really has been to take off these training wheels so that when you're no longer handed a spec for Pset 0 through 8, you at least have a sense of where to go from here. And indeed, the final project is about taking off the final of those training wheels. Now, what does problem solving itself mean? We described it back in week 0 as this. You have inputs to that problem, and at the end of the day, you care about the outputs and what was inside of this black box, so to speak. Yeah, so algorithms, just step-by-step instructions for solving some problem, and that's where the real insight is, the real efficiency, and the real opportunity to get things not only correct, but also well-designed, in addition to something like well-styled. And so as you approach the solutions of problems, I dare say maybe one of the most thematic topics of this class, and perhaps any other introductory class, is this theme of trade-offs, whether it's time and space, or the computer's time and space versus your time and space and so forth when solving these problems. And consider that there's not necessarily one right answer to these kinds of design questions, but hopefully you'll feel all the more that you can hold your own in a conversation with someone as or even more technical than you, and convince them of your perspective and contribute to the solving of some of these problems. And among the other topics that have been sort of manifest throughout the semester is this one, abstraction, which really speaks to this very general problem-solving tool. If you've got some problem ahead of you, whether it's something software-related or real world or really anything in between, this idea of sort of taking something complicated and breaking it down into its constituent parts so that you only have to think about sort of up at this level, and you don't have to worry about where the zeros and ones come from or where the characters on the screen come from and so forth. Like, the fact that we've kept layering and layering and layering means you could do so much more with Pset 7 and 8, even if it didn't feel like it at the start of the week, than you could with just C, and certainly with just binary alone. So realize, too, that sort of bootstrapping is thematic anytime you're learning some new topic. And how do you express yourself when trying to solve these problems? Of course, pseudocode. And indeed, this should become habit as well. It doesn't really matter what language you write in, but I am still in the habit of kind of writing out comments for my programs. And then therefore, I kind of know the outline, much like an English essay, and then I kind of fill in the gaps with the actual code thereafter, because the hard part, and perhaps the fun part, is really just thinking through how you might solve something. And in fact, this feels like an opportune moment to take a moment to see just how well this has sunk in and how well we might apply some of these most basic principles that started in week 0 and then persisted throughout. But for this, we need a volunteer to come up on stage and help me program everyone else. Yeah, come on up. All right? What's your name? Sorry? Amy. Amy, come on up. Nice to meet you. Now, only Amy is about to see what's on my screen. And if the staff could help me for just a moment, let me go ahead and cut to this. I'll be right back. We just need to quickly hand out all this paper. You can pull out a piece of paper of your own if you have it. But if the staff could kind of divvy these up so that everyone has a piece of paper, ideally a pencil or pen. If you don't, we have, pardon me, Amy, a solution to that problem. Everyone gets a free CS50 pen today if you'd like. OK, very popular. OK, so no one has a pencil now, apparently. All right. So Amy, as you guys get set up there, I'm about to show Amy something on my screen, a picture to draw. And you, much like the programmer that you now are going to program the audience to actually draw what you see. And we'll remember from very early on that precision is probably important here. But at the same time, you don't want to get tangled in the weeds of zeros and ones, so to speak. You want ultimately everyone in this audience, ideally, to draw what it is just you and I are seeing. All right. So everyone is unwrapping pens. And hopefully you have a piece of paper, though any piece of paper suffices. I'm going to go ahead and reveal what Amy is seeing here. And the goal is verbally only to tell the audience here what to draw. Okay. And give everyone just a moment. Get your paper in front of you, pencil in hand or pen in hand. And feels like we can begin.
Okay, so I'm looking at a cube. It's kind of like a Rubik's Cube, but I can only see 3 of the faces. So, so there's so there's the top of the Rubik's Cube and 2 sides. The top looks like a diamond. So you want to draw the diamond on the top, and then the 2 sides come down from that. So it kind of looks like you're looking at a Rubik's Cube from the corner. And it's not actually a Rubik's Cube, so don't draw the lines. It's just like a normal cube. I don't know how else to describe it.
Exit?
Exit.
OK. So thank you so much to Amy. A round of applause, if we could, for getting us to this point. Now comes, feel free to partake back down there. Now we just need the staff to really help grab some of these pieces of paper. We'll do pseudo-random samples, and we'll take a look at correctness, if not artistic design here. Some folks still going past the buzzer, but that's OK. All right. I'm going to go ahead and queue up my screen here. Just a moment. We'll actually reveal how some of these came out. All right, that's good. Thank you so much. All right, so notice in particular, though, that what Amy was doing was actually leveraging abstraction, as it turned out, right? She was telling you to draw shapes that are hopefully familiar, or toys that are hopefully familiar, and those, of course, are abstractions, because it would get pretty mundane and pretty low level if she had to start describing, like, what a Rubik's Cube is or what a diamond is. Hopefully, these are abstractions all of us know, at least the diamond shape and so forth, and the cube shape from yesteryear. So at least we have that same mental model. So let's take a look at a few of the shapes that we have here. Here we have 1, 2, 3 attempts to draw, but that perhaps is reminiscent of what some of you drew as well. This one here is super small, so we didn't really speak to scaling, but that does look like a cube, perhaps not necessarily oriented as she intended. This one's kind of cute. But we love them all equally, whoever's this is. In fairness, this one's sort of Inception-like. Or, oh, I see, diamond on top of the cube, I get it. This one's a little bloated at the bottom. OK. This one's actually quite beautiful. Here we have this one here. Very nice. And I think she was describing it this way. And in fact, if I go back to what Amy was seeing, the answer was this one here. So a big round of applause if we could for Amy. But now, let's flip things around. Here we need one more volunteer to come on up if you could. OK, come on up. And what is your name? Dylan. Dylan, come on up. So here we'll turn the tables a bit. Thank you so much. You're welcome to keep those pens and the sheets of paper if you still have them. Let me go ahead here and blank the screen again and give Dylan a piece of chalk if we could. And so if you could come on over here. What we have here is a canvas on which you can draw what the audience tells you to do. And in fact, since the answer is going to be there, we're going to push this back after all. And the only thing you can't do is look up. Okay. All right, so look straight ahead. Here's your piece of chalk. And now what the audience is going to see is what you need to draw. And we'll take it one instruction at a time to tell Dylan what to draw. All right, the drawing is... Who would like to contribute the first instruction? And Dylan, also don't look to your right, because there's answers everywhere. Yes? Draw a circle in the middle of the board. Smaller than that. There you go. Erase the big circle.
Draw a line going down the circle.
Draw a line going down the circle. OK, wait, we need to buffer. Buffer. Hang on. No. Undo. OK, let's restart. Step 1. Draw a small circle in the middle of the board, Dylan. Keep it. We'll take it. OK, step 2. Draw a stick figure with no arms yet. Nice abstraction. OK. Step 3. What's that? The circle was supposed to be the head. OK, version 2. Step 4. Step 4? Step 4?
Yeah. From the bottom of the circle, draw inverse y.
From the bottom of the circle, draw an inverse y. Step 5? Stepping from the head, the body and the legs are the same height. So draw the body first, and it will look like a Y. After erasing everything else, I heard. Yeah, OK, nice. Very. Erase the mustache. OK, step 6. Step 6? Draw a V the same way from where you started with the Y. On the right side. No, 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 no. No. Do the opposite of that. Downward V. It's one of his arms. His right arm. His arm. OK. Step 7. Draw the what? Draw the second part of the arm from the elbow. 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 Elbow, yeah. On the arm on your right, make it a V. OK, yes. OK, we'll take it. Yes, OK. Almost there, almost there. Make the other arm put his hand on his hip. Yes, and last step maybe? Second to last? Yeah? Say at 11 or 10 o'clock. From the circle. Look at the circle as a clock. And draw a line as big as one of the arms. Put a space. Yes. Last step. Yes, over here. Right high above it. Capital H. And congratulations to Dylan. That's pretty good. Pretty good. Thank you so much. So realize, fun as this is, it's actually non-trivial to convert these abstractions with which you're familiar to things that computers, or in some cases humans, actually understand. So realize here too, there's this trade-off. Like saying draw a stick figure is a very useful abstraction, but the problem, of course, is that the precision isn't necessarily there if you're seeking one particular goal. So beyond problem solving in this way and in this class, what more can you do after CS50? So if you take a look at that unofficial guide to CS that we'll link soon on CS50's website as well, you can go off in so many other directions from here, to the direction of hardware, software, graphics, theory, statistics, mathematics, and more, and indeed increasingly to the intersection of computer science with other worlds like economics and now machine learning, which is being applied to all sorts of fields as well. And in fact, even I, years ago, have very fond memories of some of these classes, and only a handful of these even existed years ago. I still remember to this day taking CS141, which is a hardware class, and even though these days much of it's been virtualized in software, back in the day we had tiny little wires and tiny little breadboards, and debugging, back in my day, was literally a matter of grabbing all of the wires that had just frustrated you to no end and literally ripping them out of something called a breadboard and starting over. Nowadays, you can do so much more in software and can conceptualize things all the more effectively because of enhancements since. And perhaps after CS50, one of my favorite classes, probably my favorite class as an undergrad was CS161, an operating systems class, where you actually build pieces of an operating system which would be akin to the features of Mac OS and Windows and Linux and the like. And so realize, even if you're among those less comfortable, there's so many different stepping stones. So do chat with your TF or myself or the course's heads or any of the CAs about what directions in which you might go. And even if you don't have the time or necessarily the interest on campus in doing these things, there are so many courses online beyond this particular campus too, on edX and Coursera and the like. So don't underappreciate the ability now to go teach yourself new things, albeit with the structure of some of these freely available classes. But how about some concrete steps now too as to what you can do after CS50 to actually solve problems and write code? Because at the end of the day, you're not going to be handed necessarily these problem set specifications. You're not necessarily going to have a TF or CA to whom you could ask questions with which they themselves are already familiar. You're a bit more on your own in terms of teaching yourself new things, so long as, though, you take advantage of these resources, can you succeed at exactly that. Now, you're welcome to continue using something like CS50 IDE for as long as you would like. Your accounts will keep working, and indeed, that's meant to be pretty representative of a real-world environment. But of course, it's cloud-based, and so if you're on a plane or a train or in some of the dorms or houses where the Wi-Fi isn't so great, might not work so well. And so increasingly common after taking one class would be to start installing these kinds of tools on your own Mac or PC. So we'll put these slides up later as well so that you have all of these URLs. But if you'd like, on your Mac or PC, whether it's over Thanksgiving or JTerm or beyond, like install some command line tools on your Mac or PC. This means having a command line environment on your Mac, as suggested here, which actually comes with Mac OS. If you install something for free called Xcode and more, you get a whole suite of command line utilities. In the world of Windows, you can actually install a command line environment that's much better than the built-in command prompt with which you might be familiar, so that it behaves just like Linux, essentially running Linux on your own Windows machine. Now Git, this is something you guys indirectly use throughout the semester anytime you ran Submit 50, but really all Submit 50 does is run a few different commands, all of them called Git. This is a version control software, and it's just one of several different versions, but Git probably has the most traction these days. And if you are still in the habit, and even occasionally I'm guilty of this too, at least in the world of like writing essays and letters, if you're in the habit of like copying a file and then naming it like version 2, or copying a file and naming it like Thursday night and then Friday morning and all of these different deltas, like that is not a good system, because you're not leveraging the computer to keep track of the differences, especially so that you can rewind back in time. So a program like Git actually lets you keep track of all of your changes, and you have an infinite history of all of the work you've ever done. And so Brian here, nicely enough, enough, has given a seminar on how to use Git and in turn GitHub. On GitHub itself, if you haven't already, you can sign up for free private repositories, which means you can store your coursework and your own work privately so they're not in public repos, since to date, all of your work has been in CS50's account, but you yourselves can start using your own. If you do this, you can just fill out the prompts like this, saying you're a student wanting an individual account for free, and then you can install Git itself on your own Mac or PC as by following instructions here. But what about actually writing code? I mean, theoretically, you can use most any text editing program on your computer, like TextEdit on Mac OS or Notepad on Windows, but these are not very good tools in that they don't have any features that are code friendly. But it's very easy to install something like this. This is super popular among students these days, Sublime Text, as well as software engineers in the real world. It gives you features like syntax highlighting and nice indentation features and even autocomplete and more. And so this would be a tool much like the IDE that you can use on your own Mac or PC. An alternative that's also free for use here is Atom. It behaves very similarly, and that too is something you can try as well. If you'd like to go a little deeper and sort of use some older school tools that are very much still in use, myself included, because they're perhaps all the more powerful and that they're much more command line based, Vim is a very popular one. And if you add this autocomplete plugin, you'll have very similar capabilities even within that environment as well. Now, as for final projects, many students end up making web-based applications, maybe borrowing Pset 7 or Pset 8 code, and then adding and contributing their own when ripping out things that are Pset specific. You can certainly use CS50 IDE to host that website so that friends at the fair and then friends in the houses and dorms can try it out, or friends back home. But of course, with these free accounts, they tend to turn off just to save resources after not using it for a few hours or days. So you can at least, though, in the short term, enable this by going to the share icon in CS50 IDE, selecting public for the application, and then any friends who visit a URL that looks like that can actually see your Pset 7, your Pset 8, or soon your final project if it's web-based. But a lot cooler, ultimately, and a lot more practical if you want this thing to survive in perpetuity and just run 24/7, would be to use some of these third-party cloud services. So Heroku is a very popular service that has you install a little bit of software on your Mac or PC, and then sort of magically thereafter, anytime you run a command, any code you've been working on your Mac or PC gets pushed to the cloud, so to speak, deployed to Heroku servers, and then it can live at your own domain name, either a default one you get for free, but if you want something a little more custom, can you actually buy or for free get your own domain name. Amazon has something called AWS Educate, which you can use for free as well, and there's bunches of other services too. In fact, there's a company called Namecheap, which is not only cheap, it's also free for students. If you want to buy your own domain name for your final project or beyond, head to a URL like this one here. And then lastly, GitHub itself, beyond offering version control software, has partnered with bunches of companies that just give free levels of service to students as well. So if you go get this developer pack, so to speak, you'll see even more options that you can use for some amount of time to learn from and actually use compellingly these kinds of services. So what remains and what lies ahead? Well, of course, we'll be seeing the CS50 Hackathon, the CS50 Fair, more on those in just a moment. But you're also at the point now where you've seen a lot of languages, right? Scratch and C and Python and SQL and JavaScript. And increasingly, if you spend time in this world of CS and programming, and if you Google and read up on Stack Overflow, you're going to find that it's a pretty religious world among some people where everyone has these strong opinions, sort of correct or incorrect. And so I would encourage you to be as open-minded here on out as to like what the right solutions to problems are. It is rarely the case that there is one thing only you should use, and realize that a lot of programmers, myself included, will bring to the table biases that you should keep in mind and push back on if you think a problem could be solved differently. And realize, too, it's all about trade-offs. And this, to kind of paint this picture of the various idiosyncrasies of languages, is a wonderful short talk that a fellow gave at a conference a few years ago, wherein he pointed out that all languages, the ones especially that he excerpted, have these weird features. And so if you encounter someone in life who's like, oh, PHP is bad because of this, or Python is bad because of that, well, you could probably come up with those kinds of sentences about any language. But what's cool now is that we've seen enough languages, and you've perhaps formed enough opinions that some of the examples you're about to see should on their face be a little nonsensical or weird, and it's more like programming trivia. But hopefully now, some 12 weeks later, these examples of programming idiosyncrasies will make sense. Let's take a look.
Go. All right, good. You guys know what WAT means? WAT. Exactly. Let's talk about JavaScript. Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be? Empty array, I would also accept type error. That is not what array plus array is. Wrong. Wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone. Now, what would array plus object be? This should obviously be type error because those are completely disparate types. Does anyone know what this is? No. Close. No. Far away. It's object. Right. Nicely done. Now, of course, because this is plus, so you can flip the operands and the same thing comes out. So if we do, what? No, that's just an object. If you do object plus array, you should get exactly the same thing, which, as you can see, you do. And finally, the only one of these that's actually true is, because you add arrays, you get empty string, that doesn't make sense. But an object plus an object is actually not a number, technically. So this one's actually right. And exactly, right? Like, what is even going on in this lab? I don't even understand what person with a brain in their head would think that any of this is a good idea. Okay. Enough making fun of languages that suck. Let's talk about JavaScript. If I say array.new 16, or just array 16, I get an array of 16 things, which it represents as 16 commas, which is obvious. And if I then join those with a string, then I get the string 16 times. This is actually the only line in this entire presentation that's reasonable. Now, if I take that string and then add a 1 to it, it interprets the 1 as, or casts the 1 to a string, and then we get wat1 a bunch of times. Fine. Does anyone know what will happen if I subtract 1 from the string? I'm assuming no one does. I'll give you a hint. Does this help? Does anyone know? Wet man.
So programmer humor, just a little taste of it there as well. So what comes next? We will wrap a bit early, probably about 10. Oh. Okay. So we'll wrap in about 10 or so minutes, but before then we want to give you a teaser of what lies ahead and why. So the CS50 Hackathon, of course, here on campus is about working on, alongside classmates, final projects and having some 12 hours or so in which to dive into them, not only to actually get something useful and productive done and feel good about it, but also we hope about having a particularly memorable experience among all of the course's staff and all of your classmates. It's not meant to be 12 hours of office hours, but really 12 hours of fun problem solving with a wonderful support structure of everyone around. Upon arrival, you'll check in like this here. You'll get set up in the HBS's hives across the river where we had CS50 Puzzle Day. And throughout the evening, will you work with each other or on your own projects, solving problems ultimately to get to an end of having a project that's either good or better or best as per your proposals. Around 9 p.m., we'll order in some Felipes, quite a bit. Around 1 a.m., we'll order quite a bit of pizza as well. And then throughout the evening, will there be not only a photo booth for some souvenir photos, one of CS50's own therapy dogs will be on display to chat with and get to know. Yes, shout out to Milo here. And then, of course, shortly after this, around 2, 3 a.m., such things as this do happen. But if you can make it through the evening at 5 a.m., we'll literal CS50 shuttles show up and take those of you who'd like to have a culminating breakfast over down the street to IHOP. And then just a week or so later is the CS50 Fair, an opportunity to show off what you've done and what you've learned to all of your classmates here, but also others across campus. In attendance every year are some 2,000 students and faculty and staff from across Harvard, some from the surrounding area, high schools as well, all of whom are here to see what you have pulled off. So here is a glimpse, for instance, of last year's CS50 Fair. We'll set up laptops and tables and music music and food, and really just have you offer an opportunity to delight in what everyone here has pulled off during the semester, and hardware demonstrations as well. Also in attendance will be some friends and recruiters and alumni from industry. Pictured here is one of CS50's former TFs who actually turned himself into a software engineer, having taken CS50 as a senior, concentrating in social studies, and then really bootstrapped himself in the few years after graduation to then have a job at Google writing software. And of course, you'll receive at the very end, hopefully, this proud statement that you took, indeed, CS50, and so that will be presented at the CS50 Fair as well. In just a little bit, we'll adjourn to the pub downstairs where Aaron and Brian and Maria and the whole team will be waiting to say hello and congratulations with CS50's traditional cupcakes. But before then, we thought we'd invite a few of the staff up on stage to participate in an annual CS50 tradition, especially in the spirit of this weekend's competition. But this one, not so much Harvard versus Yale, but students versus staff. If we might get 4 brave volunteers to come on up. Okay, so one hand over here, come on up. Okay, one hand over here, one hand over here, and a 4th hand over here. Come on up. Thank you so much to our volunteers here. Right there. That's fine, yeah. What's your name? Audrey. David, nice to meet you. Right this way. We'll get some chairs. Will, nice to meet you. Right this way. Olivia, nice to see you. Right this way. And Hannah, right this way. So we've got 4 chairs for staff, 4 chairs for students. All right, thank you. Let's put the tablecloths up there too. And Colton, we can spin this around. Let's have the students sit over there on my right. Thank you. And the staff will sit over to their left. Thank you. And here we have, excellent. Excellent. And you want to do some dramatic flair here? All right, so you guys are in charge of that one. You guys are in charge of that one. Just keep the pen and paper there. Oh, and even better, yes, let's see. Let's see if we can do a dramatic flourish here. I think we can do better for you guys. Yes. You guys get the better tablecloth. There we go. OK. All right, so you may recall as part of problem set 8, did we ask you a few quiz review questions? Not all of them made the cut into the actual quiz. There was a lot of what is HTTP stand for? And what is HTML stand for? But that's OK. We went through the list and called a few that we'll use here for CS50's annual Student v. Staff Jeopardy. So because the questions were written in the form of questions and not answers, we'll simply read them as is. We've excerpted a number of categories from which your own classmates wrote questions. We don't have buzzers, but we do have things that squeak. So we have 4 of these. So if you just squeak the duck, if you'd like to buzz in, Colton will help me adjudicate as to whose hand went up first. And let's go ahead and put a microphone here. Microphone here, and before we begin, perhaps some quick hellos of name and dorm or house into the microphones.
Hi, I'm Olivia. I'm a freshman and I'm in WIG.
Hi, I'm Hannah, and I'm a first year at Graduate School of Design.
Hi guys, I'm Will Yao. I live in Grays.
Hi, I'm Audria. I'm a senior in Mather.
And let's now meet the staff.
I'm Aaron.
Thank
I'm
you.
Arnav. I'm a sophomore in Elliott. I'm Thomas. I'm a senior in Kirkland.
Maria, senior in Cabot.
And so perfect that Maria's up here too, because I went through our archives, and if we look back some 4 years, there she is as well. When apparently it was fashionable to wear Google Glass around campus. So here we have our Jeopardy board implemented in HTML. And we have single Jeopardy ahead. We won't run the whole board, just a few choice examples from each category. Before we began, students won the coin toss, so you guys will get to pick the category and dollar amount. I'll ask a question. Colton will kindly keep track of the score, and we'll see how this turns out before we adjourn for cupcakes.
Yeah, exactly.
What topic would you guys like? Okay, scratch for 200. First one to squeak gets the answer. Which puzzle piece starts the program? I think I heard students. The yes, the when flag clicked. What color is the flag? When green flag clicked is correct for 200. Very good. Very nice. You're still in control of the board.
Let's take. You okay with memory? I don't know. Let's go memory for 400.
Memory for 400, stepping it up. So for memory, how much memory does a byte have? Also didn't make the quiz.
1 byte. 8 bits.
I'll take 8 bits, yes, for 400. Staff are now in control. Nicely done, Thomas. But yes, a byte is a byte. What category would you all like next? Oh, wait.
Algorithms for 400.
What for 4?
Algorithms for 400.
Algorithms for $400. So in algorithms, we have the following question for you. What is the big O? I heard it over here. Used to describe time complexity, correct, for $400. Wonderful. Students are in control and are currently up to 600, still taking the lead again. What would you like next? C. For 400. C for 400. We're going to go with, why did we start with C? And there's no answer, so. But go ahead. I heard you squeak first.
Because if we started with something else, going to C would be terrible.
Because if you started with something else, going to C would be terrible. Staff, what do you think?
Sure.
Yeah, all right, for 400. That was C for 400. We have time for just 1 or 2 more questions here in single Jeopardy. Students, you're still in control and really winning now.
C for 1,000.
C for 1,000. Oh my goodness. All right, remember to buzz in.
Get ready.
What is the ending punctuation to each line of code in order? I think the staff first, yes?
Semicolon, I hope.
Semicolon for 1,000. Excellent. I think then it's time for us to move to double Jeopardy here, at which point the dollar amounts increase by a factor of 2. We have time for a few questions in this category. Staff are now in control, 1,400 to 1,000.
Data structures for 2,000, please.
Data structures for 2,000. Data structures for 2,000. Here we go. Data structures for 2,000. How many children does a node have in a binary tree? Oh, I heard it over here. Yours didn't work. Your duck didn't work. Okay. 2 is correct. 2 is correct for 2,000. Time for 1 or 2 more questions. Students, you're back in control. 3,000 to 1,400. Python for 2,000. Python for 2,000. Python for okay. How do you say for $2,000 else if? You think Aaron? All right, your duck worked this time. Elif is correct for 2,000. You're now at 3,400. Okay. Don't have the support of the audience. Time for 1 more question before final Jeopardy and cupcakes. What will your category and dollar amount be?
Let's do HTTP 2000.
HTTP for 2,000. Really going to pull ahead with this question potentially. HTTP for 2,000. HTTP for 2,000. Okay. When asked for a question about HTTP, your classmate asked us to ask the following question. Laughing my ass off, just use the cat questions from the test. Asked by, okay, we'll try another. We'll try another. We're going to go with get coffee, HTTP/1.1.
Just something, I'm a teapot? No.
Yes, students.
It's the I'm a teapot error. Okay, sorry, I'm listening to you.
No, that was correct, though. Nicely done. 2000. So this was an old April Fool's joke where it was introduced as a joke. HGP 418. So now we're at time for the final Jeopardy question, where for this question you have a piece of paper and a pen. The staff have 3,400. The students have 5,000. So there's some strategy here. You're going to first need to decide on a dollar amount, knowing only what the category is. The category is going to be web programming. How much would you like to wager on web programming?
All of it. All of it.
Oh, I don't think you're supposed to tell me yet. In Jeopardy, yes. So wait, and we also need, let me grab just our song here. Stand by 1 second. And students, if you could write down how much you want to wager, strategically not knowing what the staff is wagering. We need, here we go. Okay, so you are wagering some amount, and you guys are wagering, okay. So the question is, and you'll have 34 seconds to come up with your answer. This is a real question by one of your classmates. Here we go. The creator of a hybrid language allowing users to meld HTML and Python had what color hair? So we're going to take a look first at staff, who were trailing with 3,400. They wagered, turns out all of it, and answered red hair. The students, meanwhile, at 5,000, wagered 1,900 and went with brown. I think we're going to need to have the audience decide whether or not the staff's answer is correct, because according to your classmate who gave us the question, the creator of a hybrid language allowing users to meld HTML and Python had what color hair? The answer is ginger. So congratulations to both staff and to students. Thank you so much for a wonderful semester. Cake is now served downstairs in the pub. We'll see you at the hackathon and fair.